Hello guys, welcome to Pre-Algebra. Today, we'll learn about lesson 5-7, subtract expressions. In this lesson, we'll be able to subtract expressions using properties of operations. Let's look at explore it. The East Side Bulldogs and the West Side Bears are playing a football game. A fan is keeping score using T for a touchdown plus extra point worth 7 points total. An F for a field goal worth 3 points. So T is a touchdown and it's worth more than F, but they're all types of points. So good points, except T, every T, you add 7 points, every F, you add 3 points, okay? So we got East Side Bulldogs, West Side Bears. The first quarter, East Side Bulldogs got 2 touchdowns, so 7 times 2 is 14. And 1 field goal, so that's 3 points. So 14 plus 3 total is 17 points. West Side Bears got 3 field goals, so 3 times 3 is 9. So 9 points versus 17 points. So East Side Bulldogs was ahead of the game after first quarter, and so on, okay? Let's look at part A. How can you represent the score of each team using expressions? Can we use an expression to represent the scores for each team? First, we need a set of variable. We can have the number of T's be T, the number of F's be F, right? So for each team, you can count the number of touchdown scores. Let me write that down and come back. Okay, so for each team, you can count the number of touchdowns scored and the number of field goals scored. And we can say T is the number of touchdowns, F is the number of field goals they scored. So if we count that, East Side Bulldogs have 1, 2, 3, 4, 5, 6, 7 T's that we can see. So let's say 7T plus how many F's? 1, 2, 3, 4, 5, 6. That looks like an F, right? 6 F's. What about West Side Bears? West Side Bears has 1, 2, 3, 4, 5 T's and 1, 2, 3, 4, 5 F's. Okay. Number of points for touchdowns. Number of points for field goals. Okay. So using this, we counted how many T's and F's there are for both of them. We know that T is worth 7 points and F is worth 3 points. So we can substitute 7 and 3 into the variables T and F to solve the total points. Okay. Part B, how can you represent the difference of the team scores using an expression? Difference means subtract, okay? So you can subtract one with another. You subtract the parts of the expressions from part B to find the difference in the team scores. So you can say, I can subtract 7T plus 6F minus 5T plus 5F. So then that becomes 7T plus 6F. You need to get rid of the parentheses because we're subtracting this whole expression. That negative needs to be distributed out. So that's minus 5T, and you need to subtract 5F as well. So 7t minus 5t together and 6f minus 5f together, like terms. Combine the like terms and you can get 7 minus 5 is 2t. 6 minus 5 is 1f. So plus f. Okay. Part C. How can you determine how many more points the winning team had than the losing team? So we don't know who's the winning team, but if we subtract one from the other, we can either get the difference in a positive value or a negative value. So we can say, oh, this team had this much more points, or this team had this much less points than another team. Okay. So first, you can calculate the points for each team. East side Bulldogs will be 7 times 7 plus 6 times 3. So that's 49 plus 18, which is 67. And then West side Bulldogs, West side Bears would have 5 times 7 plus 5 times 3. So 35 plus 15 is 50. So who has more points? The East Side Bulldogs. So how do we find the difference? How do we know how many more points they earned? By subtracting and finding the difference, right? So 67 minus 50 is 17. So East Side Bears scored 17 more points than the West Side Bears. Okay, there you go. So first, we need to write the expression. Your variables could be either the number of touchdowns and field goals or the number of points of touchdowns and the points of field goals. But you need to know how to compare them by using substitution. All right, focus on math practices. How can looking at the coefficients help you determine which team scored the greater number of points? Looking at the coefficients here. Can you guess without calculating them? 7t plus 6f versus 5t plus 5f. Well, we need to know that t and f are worth different points. So the more t's you can get, might get a bigger chance of winning because it's worth more points. So it's better to compare the t's than the f's, to compare them just by looking at them. Okay, let's write the answer down. Okay, so also you can think about comparing both coefficients. If both of them, both of the coefficients for t and f are greater, then of course that team absolutely wins, and you can see that it's much greater than the other. But if the coefficients for the f is not great, or is less than the other team, but then the coefficient for t is greater than the other team, it has more chance. It still has a better chance of having scored more. So in this case, East Side Bulldogs both have coefficients greater than West Side Bears. So you can certainly say that East Side Bulldogs will score better, even without calculating it. All right, that was a long explore it question. Now that we've explored it, let's ask the essential question. How can properties of operations be used to subtract expressions? Example 1, subtract expressions by using properties. Lita's family wants to put a tile border around their swimming pool. What expressions represent the total area of the border? So this is the tile border that they want to install, right? In order to find the area, you need to find the area of the different rectangles, right? The width here is 2 feet. The height here is going to be 2x plus 14 feet, and same here, okay? Here, it's 14 feet times 2 feet. But what about this squares over here? How do you get the areas of these squares? You know that this must be 2 and that must be 2. So you can multiply because of the width of the rectangular sides here, right? So 2 times 2 is 4. You can multiply that by 4 and add it. So in order to get the total area of the border, you have to divide them into pieces and think about the areas for the rectangles and the squares. So 2 why is it? Yeah, the length of the tile border. So they're getting the total length over here, right? So another way to solve this is to find the area of the total pool, including the tiles, then subtract the water area. So we're gonna use subtraction to figure out the area of the tile. So the length of the tiled border outside is going to be 2 plus 2 plus 2x plus 18. 2x plus 14. So that's 2x plus 18. Okay. And then width of the outer edge would be 2 times, wait. We're not doing area. 14 plus 2 plus 2. So 14 plus 2 plus 2 is 18. So we have 2x plus 18 times 18 feet. Area of the pool is 18 times 2x plus 18. And then area of the pool plus tiles would be that. Area of the pool, you have to multiply the length of the pool times the width of the pool, which is 14 times 2x plus 14. So area of the pool plus tiles minus area of the pool will give you the area of the tiles, right? So we're getting the entire area here. We're going to subtract this part so that we can get the area of the tiles. All right, so we have 2 expressions, subtract them. Negative 14 using distributive property needs to be distributed out as negative 14 times 2x and negative 14 again times 14. Okay, that negative comes with the 14 together, okay, when using distributive property. And then combine the like terms, we'll get 8x plus 128 feet as the tile border. All right, that was an example of subtraction of expressions. Let's look at try it. See if you can do this by yourself. Come back when you're ready for answers. A frame holds a picture that is 15 inches long and X inches wide. The frame border is 3 inches wide around the picture. So picture this. Frame holds a picture, and this is the frame. Picture is in here. Okay. And then, oh, maybe it's not a square. So 15 inches long and X inches wide. If the frame border is 3 inches wide, so that's 3 inches wide around the picture. What expression represents the area of the frame border using subtraction? So area of the entire frame. So what is the length of the entire frame? 15 plus 3 plus 3, right? 3 plus 3. What about the width? We have x plus 3 plus 3. So simplify that. 15 plus 3 is 21. And x plus 3 is x plus 6. So then area of the entire frame has to be 21 times x plus 6. And then area of the photo is simply 15 times x, so that's 15x. So that makes the area of the frame equal to distributed property 21x plus 126, sorry, and then minus 15x. And so that gives you 21 minus 15 is 6x plus 126 inches squared. There you go. Convince me. Why can you choose to add or subtract when subtracting an expression? Why? Where can you say, oh, we're going to add this? And where do you say we're going to subtract? Subtraction is the same as adding the opposite for both numbers and algebraic expressions, right? So when you say, oh, for example, if you have 3 minus 3 equals 0, right? It's also 3 plus negative 3 will to be equal to 0. They're equivalent expressions, right? So adding and subtracting, they actually can be the same thing. Okay. Look at the next page. Example 2. Subtract expressions with rational coefficients. Jada is comparing membership costs for 2 gyms. What is the difference in membership costs after N months if she joins Be Strong instead of Zippy Health Club? So let's look at this. Zippy Health Club costs $49.95 to join and is $19.95 per month. And Be Strong would be $10 off the first month. Ooh, and without a joining fee. So first month, you only pay 24 minus 10, so $14.99 per month, but then that's only for the first month. You have to pay $24.99 the next month, and after that. So we don't know how many months she'll do, right? But we can write an expression for each membership costing N months and subtract them in order to find the difference in membership costs. So first, Be Strong, 24.99 M minus 10, because we get 10% and $10 off the first month, but we still need to pay 24.99 every month, right? So that would be the cost for N months for Be Strong. Zippy's Health Club, you pay $49.95 to join, so that's already paid. So you add it to the number of months you pay. But it's cheaper every month, right? $19.95 a month, 5 times M. And then you can use distributed property to distribute the -1 out. And so 19.95 M becomes negative. And 49.95 also becomes negative. Combine like terms. This is the difference between Be Strong and Zippy's Health Club. So Jada will pay $5.04 more each month at Be Strong, but we'll start with an initial savings of $59.95. This is how you read and interpret the answer. Why? Because M is the number of months. And this expression that we just got, the difference of the expressions What do they mean? They mean how much that she's gonna save when she chooses ZP Health Club, other than Be Strong. So this represents, the first term represents the cost for every month. But then this represents the first time payment. So the whole thing is a payment, right? So if you have a positive term coefficient, that means you need to pay that much. If you have negative number, then you don't have to pay that much. So that means she'll pay $5 more, about $5 more each month here, Be Strong. And she can start with an initial savings of $59.95 when she chooses Be Strong. So the longer she goes into one club, she will save more in ZP Health Club. But if she just goes just few months, then it might be cheaper to choose Be Strong. Okay, let's try it, see if you can subtract these terms. Multiply out the negative first. So 0.95x minus 0.04 minus 0.99x plus 0.13 would be your expression, equivalent expression without the parentheses. So combining like terms, you're going to get negative 0.04x plus 0.09. Okay. Right, example 3, subtract more complex expressions. Okay, you can subtract the expressions using the distributive property. If you have more than 2 terms, make sure you multiply the negatives to all the terms when you have a negative. Okay, so then you can change that to addition and multiply the negatives out in your parentheses, your second expression, so that you can just get rid of the parentheses without distributive property. And then you can add the like terms and simplify. That is your answer. See if you can do this by yourself. Try question number 3. Subtract 17 plus 4.5m plus 8k with 7.5m minus 9 plus 4k. You can change that to addition. 17 plus 4.5m plus 8k plus negative 7.5m plus 9 minus 4k. So change the signs in your expression. Okay, and then you can group the like terms, 17 and plus 9. We have 4.5n minus 7.5n. We have 8k minus 4k. And combining like terms, we have 4k minus 3m plus 28. All right, so that was our lesson 7. In summary, in order to subtract expressions, you can use the properties of operations and make sure you distribute the -1 out using distributive property when you see the subtraction sign with the parentheses. All right, that was lesson 7, subtracting expressions. We'll continue with our last lesson in the next video. Bye.